Hi everyone, in this video we're going to be evaluating, simplifying, rationalizing, converting, and performing operations with radicals. First, let's evaluate radicals. Here are the following steps. Step 1, determine the prime factors of the number under the root. Step 2, write prime factors in groups. And step 3, simplify. So we all know that radical 36 is positive or negative 6. When we have the cube root of 27 over 8, I want to break this down. And I want to rewrite it. So it's the cube root of 27 over the cube root of 8. What number times itself 3 times gives you 27? That's 3. And what number times itself gives you 8? That's a 2. 3 halves. Now, if we look at the next problem, the cube root of negative 27 over 8. Now, again, you still ask yourself, how many times, what number times itself 3 times gives you negative 27? Well, that's going to be negative 3, because if you do negative 3 times negative 3 times negative 3, that's going to give you negative 27. So negative 3 halves. Then I have the fourth root of negative 625. I'm going to break this down. So I'm going to have the fourth root of 625 times the fourth root of negative 1. What number times itself 4 times gives you 625? Well, that's going to be 5. And we're going to leave the fourth root of negative 1. Obviously, that's going to be an imaginary. Next, we're going to simplify radical expressions with variables. Here are the following steps. Step 1, simplify radical expressions using factoring. And step 2, simplify radical expressions using rational exponents and the laws of exponents. Okay, so notice here there's no index. When there's no index, we all know that there's a 2 here. So let's just break this down. So I want the square root of 18 and then the square root of x to the 5th. So we can break down the square root of 18. What's the largest perfect square to go into 18? That's going to be radical 9 times radical 2. And that's going to simplify. Obviously, radical 9 simplifies to 3, radical 2. Now, let's look at when I have the square root of x to the 5th. Really, if you wanted to rewrite that, it would be the square root of x times x times x times x times x. There obviously would be 5 x's underneath the radical. Now, I like to break this up and ask myself how many times does 2 go into 5 and regroup them. So I want to group it as the square root of x to the 4th and the square root of x, which is equivalent to radical x to the 5th because you would just add your exponents. Now remember, since there is a 2 here, this is technically x to the 4 over 2, which simplifies to x squared, and you leave radical x because you can't simplify that. So if you put your answers together, you would have 3 x squared, what's outside the radical, and then you could put in 2 and x together. So 3x squared, radical 2x. Next, let's look at the next question. We have the fourth root of x to the 4th, y to the 4th. So again, I'm able to rewrite this power over root, or I can just divide, right? So this is really x to the 4 over 4, y to the 4 over 4, which just simplifies to xy. 4 goes into 4 once, 4 goes into 4 once. And then next I have the cube root of negative 24y to the 6. Again, I want to separate them. So I'm going to have the cube root of negative 24 and then the cube root of y to the 6. I'm going to break down the cube root of negative 24 to be the cube root of negative 8 and the cube root of 3. because negative 8 times 3 gives you negative 24. The cube root of negative 8 is negative 2. Now let's look into the cube root of y to the 6. Again, you could rewrite that as y to the 6 over 3, which just simplifies to y squared. Put it together. So I'm left with negative 2y squared cube root of 3. Next, we have rationalizing. So here are the following steps. Step 1, multiply the numerator and denominator by the radical in the denominator. Step 2, simplify all radicals. So notice that I have 1 over radical x. We're not allowed to have a radical in the denominator. We have to rationalize. So for example, I want to multiply both the numerator and the denominator by radical x. Because think about what happens. If I have radical x times radical x, that's going to really give me radical x squared with the index of 2. So this is really x to the 2 over 2, which is equivalent to just x. So when I multiply radical x times radical x, only the radicand, the number underneath the radical, pops out. And 1 times radical x is just radical x. Let's try the next one. Radical 2 over 3. Again, I like to rewrite this. So I have a radical in the numerator and in the denominator, radical 2 over radical 3. Again, I want to multiply the fraction by radical 3 over radical 3. Radical 3 times radical 3 is really radical 9. Radical 2 times radical 3 is radical 6. And radical 9 turns into 3. Radical 6 over 3. Next, I have 1 over the 4th root of x. Now, I have to say to myself, if I have the 4th root of x, which is really x to the 1/4, what do I have to multiply that by in order to just get x? Because I don't want a radical in the denominator. Well, I have to add my exponent, so I want to multiply this by x to the 3/4, right? 1/4 plus 3/4 is 4/4, which is equivalent to 1. And how would I rewrite this? Well, I would rewrite this as the 4th root of x cubed. So that's what I would multiply both the numerator and the denominator by. The 4th root of x cubed. 4th root of x cubed. So I would get the 4th root of x cubed over x. Next, I have the 5th root of x squared over y cubed. So again, I like to separate. So I have the 5th root of x squared over the 5th root of y cubed. Now ask yourself right now, what would you have to multiply the numerator and the denominator by in order to get just y in the denominator? If you said the 5th root of y squared, you would be correct. Because I would add 3 plus 2, which gives me 5. And then the 5th root of y to the 5th is just y. So I get y in the denominator. And then I would have the 5th root of x squared, y squared. Next, we have converting radicals to exponentials and converting exponentials to radicals. So remember, for any real number, a, integers m and n are greater than 1. We have a to the m over n is equal to the nth power of a to the m. Remember, this is power over root. So let's look at our first example. We have radical x plus y cubed. Remember that if we don't see an index, there's a 2 there. So what we really have here is x plus y to the 3/2. In B, we have 3x times the 5th root of x squared. So I'm going to rewrite it as 3x times power over root x to the 2/5 fifths. Now, because I have a fraction here, I can rewrite x to the first power as x to 5 over 5. And then remember, when I'm multiplying, I'm adding my exponents. So I have 3x to the 7 fifths. 5 over 5 plus 2 over 5 is 7 fifths. Let's look at A. X to the 2/3 times y to the 1/3. So again, power over root. I'm going to rewrite this as 3 as my index. And then I'm going to do x squared times 3 again as my index, y. Again, because the index match, you can combine them. So I have the cube root of x squared y. Then next, I have z to the negative 1/2. Remember, when you have a negative exponent, it goes to the denominator. So I really have 1 over z to the 1/2, which is really 1 over radical z. But again, I want to rationalize this because I don't want to radical in my denominator. Multiply by radical z over radical z. I'm left with radical z over z. Next, we have operations with radicals. In order to add and subtract, the index and the radicand must be the same. And in order to multiply and divide, the index must be the same. So let's look at A. 2 radical 80 minus radical 125. Let's simplify the radicals. So let's see. I have 2 times, what's the largest perfect square to go into 80? That's radical 16 times radical 5. Radical 16 turns into 4, so 2 times 4, radical 5, minus radical 25 times 5. The largest perfect square to go into 125 is 25. So that gives me 5 radical 5. Multiply 2 times 4, which gives me 8. 8 radical 5 minus 5 radical 5. And all I have to do now is subtract my coefficients because I have the same radical radicand and index. So 8 minus 5 is 3. 3 radical 5. Let's look at B. I have radical 2 plus 1 over radical 2. Now, I want to put this over 1. And in order to add fractions, I have to have a common denominator. So I want to take radical 2 over 1. And I want to multiply that by radical 2 over 2 to get my denominators to be the same. So we know that radical 2 times radical 2 is radical 4. Radical 4 is 2. So we have 2 over radical 2 plus 1 over radical 2, which really gives me 3 over radical 2. But again, we need to rationalize our denominator because we have a radical in the denominator. So I'm going to multiply both the numerator and the denominator by radical 2. So I'm going to get 3 radical 2 over radical 2 times radical 2 is radical 4, which simplifies to 2. Let's look at C. So we have 3 times the cube root of 8xy times 2 times the cube root of x squared y cubed. Okay, so for this question, I'm going to multiply the coefficients 3 times 2. That's going to give me 6. And then what I'm going to do is I'm going to put the numbers and the variables underneath the cube root together. So I'm going to have the cube root of 8. I'm going to combine the x's. So this is x to the first times x squared, which is x cubed. Y to the first times y cubed is y to the fourth. Then I'm going to break it down. So I'm going to have the cube root of 8, the cube root of x cubed, and the cube root of y to the fourth. We all know that the cube root of 8 is 2, because 2 times itself 3 times gives you 8. And then if I have the cube root of x to the third, that's just x. And then because I have a fourth power here, I want to break this down to the cube root of y cubed and the cube root of y. Because remember, y cubed times y is y to the fourth. I'm just rewriting it. So let's see. The cube root of y cubed just simplifies to y. So I'm going to put this all together. 6 times 2 is 12 times x times y times the cube root of y. Now, go on to the challenge questions and simplify.